Yep.
Okay, so in other words, I've taken this one, the other side, and then I've taken this one, the other side.
That's it.
Yes. So once you've done that, then you can call this one our expression 1. So we have used conservation of momentum. Likewise, for conservation of energy, we are going to do the same. Conservation of kinetic energy, we shall say that a half m1 u1 squared plus a half m2 u2 squared is equal to a half m1 v1 squared plus a half m2 v2 squared. And from this, you can see that the half cancels out all through. And likewise, you can see that when you bring the m's on one side, you can have m1 into brackets u1 squared minus v1 squared being equal to m2 v2 squared minus u2 squared. And this is our equation 2. Now, when we divide 2, you can divide equation 1 by 2, or you can divide 2 by 1. The choice is yours. So, let's have 2 divided by equation 1. Hope that you're following.
Yep.
Okay, so we shall have m1 into v1, no? m1 u1 squared minus v1 squared out of m1 into u1 minus v1. This is the same as m2 v2 squared minus u2 squared divided by m1 into v2 minus u2. You can now guide me from here. What should I, let me just write up here. What should I write from that step?
With
You can see that this mass here cancels with this mass, even this one cancels with this mass. All right?
yeah.
Okay, so we have
Yes.
u1 squared minus
v1 squared. u1 minus v1.
v1 being equal to v2
v2 squared minus u2 squared.
Correct, divided by v2 minus u2.
That's u2.
All right. So from there, what do you know about the difference of two squares? Because you can see that in the numerator have difference of two squares. We have u1 squared minus, what do you know about that? A squared minus b squared, what do you get?
C squared.
No.
I'm sorry. I'm sorry. I was forgetting these things. It's is it AB squared into minus 2AB?
Okay, it's fine. Let's go through it here very fast. Okay, in other words, a squared minus b squared is always equal to a plus b into brackets a
plus b
minus b. Always.
Okay.
In other words, when you have a plus b into a minus b, this is the same as a times a, which is a squared, minus a times b, which is ab, then plus this time this will get plus ab, then minus b squared. So that's why this one here cancels out. You end up with a squared minus b squared. So whenever you have a difference of two squares, that is what you get. Meaning, therefore, that this is the same as the numerator have u1 minus v1 into U1 plus V1 out of U1 minus V1 is the same as V2 minus U1 minus U2 into brackets V2 minus, plus U2, everything out of V2 minus U2. And from here you can see that one of them cancels out. This one here cancels out. And we shall end up with rubbing off
U1
one at a time. Okay.
Okay.
So we are having U1 plus V1 equals to V2 plus U2, which implies therefore that U1 minus U2 is equal to V2 minus V1.
V2, V1, yeah.
Okay. So that is our relationship that we wanted. That is our relationship that we wanted. Now, the question now is, after having looked at this, of course, we're going to use this expression in the derivations of other very many formulae. And the other formula, I will be showing you this. But at the moment, let's try out some numbers here. The numbers that I sent you.
Okay.
WhatsApp. Just to fill the numbers and then we call it night. We started at around 10 past 9, so we have some 7 minutes.
Yeah.
We have some 7 minutes. Okay. Can I remove this?
Yes.
All right. All right. So, I know you're using your phone, so you may not be able to read this, but let me read for you the questions here. I don't know if I have them. Let's see. Let me check if I don't have them. Just a moment here.
Collides with a 3-kilogram object moving with a velocity of 6 meters per second along the same direction. If the collision is completely inelastic, calculate the decrease in kinetic energy collision.
Okay, correct. So you can have this, you can get somewhere and write this. In case you had tried them out, it's okay, you can follow your working. So I took a balance body of mass, of moving with a velocity of 8 meters per second.
Yeah.
Collides with a 3 kilograms body moving with a velocity of 6 meters per second. And this is before.
Yeah.
In the same direction, if the collision is completely inelastic, in other words, it is perfectly inelastic, in other words, they move together.
Yeah.
We shall have 3 plus 2 kilograms. The common velocity would not know it. So calculate the change in kinetic energy. So what you're going to do, we're going to calculate for the total kinetic energy before collision, total kinetic energy after collision, and then you get the difference in the two kinetic energies. So this is after. Let's first get the final velocity after collision. We shall say that from the conservation of momentum, we shall say that m1 u1 plus m2 u2 is equal to m1 plus m2 into v. So we have 2 times 8 plus 3 times 6 is equal to 2 plus 3 into v. So what is the value of v? This implies that our v equals
5.
You get 5?
Yeah, 5.
Okay, let me check. 2 times 8 plus 18.
6. Oh, sorry.
Divided
Answer.
by
Sorry,
5.
it's 6.8 meters per second.
Correct.
Calculated.
6.8 meters per second. So after having done this, then we get the total kinetic energy. Total kinetic energy before.
Mm-hmm.
Before, so we shall have a half m1 u1 squared plus a half m2 u2 squared, which is the same as a half times 2. The mass was 2. The mass is 2 kilograms, 8 meters per second.
Yes.
So times 8 squared.
8 squared
Then plus a half times 3
plus a
times 6
half
squared.
times 3 times 6 squared.
Okay, so what do we get here?
118.
118, correct. 118 joules, correct. Then after collision, we shall say that kinetic energy is equal to a half times 2 plus 3 times our velocity is 6.8 squared. Remember the final velocity was 6.8.
Yeah.
So we have 6.8 squared. 4 times 5.
Answer is 115.6.
115.6 joules, correct. Therefore, the loss in kinetic energy will be equal to 118 minus 115.6, which gives us
2.4 joules.
2.4 joules. So in other words, it means that if the kinetic energies are not the same, then it wasn't conserved. Wasn't conserved. So that is number one.
Yes.
Number one. Number two, how does number two read?
Two bodies, A and B, of mass 2 kilograms and 4 kilograms, moving with velocities 8 meters per second and 5 meters per second respectively, collide and move on the same direction. Object A's new velocity is 6 meters per second. Question 1, find the velocity of B after collision.
Okay. So collide and move on in the same direction. Object A's new velocity is 6. So in other words, they separated. We have A, we have B, and then we have A, we have B. So this is of mass 2 kilograms. Velocity is 8 meters per second.
Yeah.
This is 4 kilograms. Velocity is 5 meters per second.
Per second.
Moving with the velocities, okay. Respectively collide and move on in the same direction. Object is new, okay. So this is velocity v1 equals to 6 meters per second.
Yes.
So find the velocity of body B. Find the velocity of body B. And then find the percentage loss in kinetic energy. Okay, let's begin with the first case. We shall say that M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So you have 2 times 8 plus 4 times 5 is equal to 2 times 6 plus 4 times V, implying that our velocity V equals, I'm waiting for the answer. So 16 plus 20, that is 36. Minus
36.
by 4.
36 minus 12, 24. 6.
6. I'm getting 4.5.
What?
Am I wrong? You're wrong.
You're wrong.
I sure. Okay. So
Well, yeah, because like if the final answer,
this is 16.
is 6 meters.
Then plus 20, all right, equals to 12 plus 4v.
Yeah.
So this is 36 equals to 12 plus 4v, implying that
equals to
4v,
24. 36 minus
36 minus 12.
12.
You
get 24.
24. Okay, so v is equal to 6.
Yeah.
Okay. All right. Then, part B was saying that find the percentage loss in kinetic energy. How to find the percentage loss?
I think you have to find the total kinetic energy and then subtract it from total kinetic energy minus the kinetic energy that was gained, or the kinetic energy that was there at first. Not too sure about that. I'm not too sure about that.
The percentage loss in kinetic energy, percentage means that we're going to multiply by 100%, right? So shall get the loss in kinetic energy, then divide by the original kinetic energy. Kinetic energy before. Then times 100%. So let's get the loss in kinetic energy. So kinetic energy before is equal to 1/2 times 2 times 8 squared plus 1/2 times 4 times 5 squared. What do you get?
That's 1/2 times 4 8 squared. That's 64 plus 128.
Is it 28?
192.
Are you sure? So the first one is 64.
Well, you said, yeah, the first one is 64 and the second one is 128.
1/2 times 4 times 25.
Oh, that's sorry, silly me. I made a mistake. I put 8 again.
Okay. So I'll get my answer as 114 joules.
Yes, 114 joules.
Then kinetic energy after, this is the same as 1/2 times 2 times 6 squared plus 1/2 times 4 times 6 squared.
Okay.
In other words, it will be, okay.
36 plus 72. 108.
108. All right. 108 joules. Have you got these answers, by the way?
Yes.
So loss in kinetic
Well,
energy, you're lying me.
no, like you said, have you got these answers? So like I'm calculating with you.
Oh, okay. I was asking that, did you get, all right. So the loss in kinetic energy will be equal to the original minus the final, which gives us 4 joules. No, 14 joules, I think. 14 joules. So the percentage loss will be equal to
114 minus 108 is 6.
Okay. Is 6
Yeah.
joules. All right. Then our percentage loss in kinetic energy will be equal to the loss in energy divided by the original, then times 100.
Divided by the kinetic.
What do we get?
5.2.
5.26%.
5.26.
All right, that is number 2. Number 3.
A particle of mass 2 kilograms moving with speed 10 meters per second collides with a stationary particle of mass 7 kilograms. Immediately after impact, the particles move with the same speeds but in opposite directions. Find the loss of kinetic energy during collision.
Okay. So this is what we have, a particle of mass 7 kilograms initially at rest, meaning that its velocity is 2 meters per second. This is before. And after collision, this one is moving this way, this one is at rest. So after colliding, this one moves this way, this one moves the other side. This is 2, this is 7. They move with the same velocity, with the same speed. So if this is V1 equals to V, even this one here, V1 will be equal to V, but this one is going to be a negative.
Oh.
Be a negative. Because remember that velocity is a vector quantity.
Yes.
So from the conservation of momentum, we shall say that 2 times 10 plus 7 times 0 is equal to 2 times negative V plus 7 times V. In other words, if anything is going this way, give it a negative. If anything is going the other side, give it a positive.
Positive.
Yes. So you shall have 20 being equal to, this is negative V plus 7V, shall get 5V, implying that our V is equal to 4 meters per second.
Yeah.
Okay. So the question was saying that find the loss in kinetic energy.
Yes.
Find the loss in kinetic energy. So before, kinetic energy will be equal to 1/2 times 2 times 10 squared plus 1/2 times 7 times 0 squared, and this will give us 100 joules. Then after kinetic energy, what should I write here?
1/2 times, is it -2?
The mass
Since it's
2.
moving in the opposite direction.
Okay.
Yeah, the 1/2 times 2 times.
Okay, one thing that you need to remember is that kinetic energy is a vector, is a scalar quantity.
Okay.
Yes. Kinetic energy is a scalar quantity, not momentum is a vector quantity. Vector quantity. And then 2, kinetic energy is a scalar. So scalar means that you don't take consideration the negatives. Simply everything is a positive. That's what it means. So we have 2 times 4 squared plus a half times 7 times 4 squared. And what do we get here?
That's 16 plus 56. 72?
72 joules.
Yeah, 72 joules.
Therefore, the loss in kinetic energy will be equal to 100 minus 72, which gives us 28 joules. And yes, it is done.
Okay.
All right, we move on.
Yeah. A 2-kilogram object moving with a velocity of 6 meters per second collides with a stationary object of mass 1 kilogram. If the collision is perfectly elastic, calculate the velocity of each object after collision.
Okay. 1 kilogram, 0 meters per second. This is before. And then after collision, if the collision is perfectly elastic, calculate the. Okay, so we shall assume that this one is going this way with the velocity v1, and this one is also going this way with the velocity v2. This is 2 kilograms. This is 1 kilogram. So this is after. How do we go about this? The solution, we can simply say that our 2 times 6 plus 1 times 0 equals to 2 times v1 plus 1 times v2. Now, I am assuming that everything is going in the positive direction.
Yes.
So meaning that we shall have 12 being equal to 2v1 plus v2. This is our first equation. And recall, for a perfectly elastic collision, u1 minus u2 is equal to v2 minus v1, meaning that u1 was 6 minus 0, we shall get the same as v2 minus v1. So 6 is equal to v2 minus v1. So those are 2 equations, equations 1 and 2. With 2 unknowns, v1 and v2, that one gives us a simultaneous equation. So from there, you can solve them simultaneously, and you get the answer.
Yeah.
Solve 1 and 2 simultaneously gives v1 equals and v2 equals. So the idea here is simply to bring in this. I say that in case you don't remember this, then go back to the original method of using both momentum and kinetic energy, and then you solve the 2 equations simultaneously.
Yeah.
So that is what we have.
Okay.
All right. So I'm going to stop here for now. I hope that you can solve them simultaneously.
Yeah, I can.
All right. So I'm stopping here for now. We shall meet, I think, tomorrow. I will be updating you.
Oh, tomorrow is Friday, but okay.
The clubs were
No,
stopped.
like you said, I was